Alper Kamil Demir from Turkey.
Hey, Albert, nice
Hi.
to meet you, Alper. Thanks for joining. Okay, it's 1 p.m. Welcome to ICNRG. So this is the IETF research group on information-centric networking. My co-chair is Dave Aran. He's joining online, and my name is Dirk Kutscher. And yeah, the usual note well. So we are in the IETF, and we are largely following the IETF intellectual property rights disclosure rules. So in essence, that means if you contribute something or you hear something that has IPR relevance, you are expected to inform us in a short time. Okay, so we are being recorded. Please mute your microphones if you're in the room. And please scan the QR code and use the online tool if you want to ask questions. So you have to anyway use the online tool and use the queuing function there if you want to ask questions. Quick reminder, so this is internet research. We are not doing standards. So we are largely concerned with topics that might become useful for future standardization. So this is about finding out like future directions and especially doing experiments on those technologies and those ideas. And so when we publish RFCs, it's most often about experimental specifications. So about some systems that could be implemented, could be tried out, but not about standards. Okay, so yeah, we joined the mailing list. We still need a note taker for today. So some people came late. They are naturally the candidates for this job. So we cannot run the meeting without a note taker, and I can't do it because I have to run the slides, and Dave also needs to help me with that. So we need somebody in the room. It's a really easy job. So, and Colin can also not be taking notes. He has other things to do.
It's helpful if it's somebody in the room, obviously, rather than a remote person.
Yeah. I can take some notes, but they will be very coarse. Thanks, much appreciated. Okay, thank you. So Jörg Ott is taking notes. Thank you very much.
Thank you, Jörg.
Yep. All right, so this is the agenda for today. So maybe quick explanation. So we decided to focus today's meeting on a discussion about kind of distributed computing, in particular about transactions in ICN. So this has to do with a couple of topics, you know, like remote procedure calls, coordination in a distributed system, and also maybe things like RESTful communication for future web systems. And so these presentations here will kind of all discuss these topics. And so we have, I think, some material that is really good for discussion. So we hope we can have some really interactive discussion on these things. So let's try to do this today. So we have 90 minutes, and first of all, let's check a little bit our status. So thanks everybody for working so hard on getting these RFC published. So we have 4 RFCs published recently, and so let's start with the time encoding one. So that is basically so RFC 9510. a more compact time encoding for CCNX, time value encoding. And then we have this group of 3 RSCs that have to do with say tools and say management support for ICN. So both the trace route and the ping specification, they rely on a capability called path steering. That's also useful for other purposes, but so in this ping and trace route specification, you can see how you can use path steering for collecting information about an information-centric network and its elements. So yeah, great outcome. And these are really nice specifications.
We should quickly point out that these are somewhat agnostic to the underlying protocol details and have encodings for both CCNX and NDN. So you don't have to choose your protocol poison in order to use these tools.
Yeah, exactly. And so we have a couple of active drafts that we also want to complete, especially the first one, FLIC. So that's a really important specification for ICN systems. So that's about a manifest technology for file-like collections, and so it's kind of really useful in a couple of application scenarios. And so we will hear later from Mark. So one idea how these things could be used. So we also have the reflexive forwarding draft that we adopted recently. And so Dave, Hitoshi, and I'm currently working on an update, so on a new submission that will hopefully come up shortly after the IETF. So if you're new to this, this is a specification about like client-server-like communication scenarios where you contact the server and the server wants to get back to you to fetch more data in an ICN native way, so without disclosing prefix, for example. And so we use this for different scenarios, so for remote procedure calls, but also for IoT calling home scenarios. There is an implementation for NDN that one of my students did, so that would be good if that could also get more review and more comments on the main list. So the flow balance draft, Dave, that got refreshed last year. Do you want to say?
Yeah, it's sort of like sitting there. One of the conundrums we've had with how to do congestion control for ICN protocols is that there are opportunities, given that we do stateful forwarding, of doing smarter congestion control than just active queue management. And part of the ability to exploit that is actually to know how much data to expect back when you issue an interest. And the underlying problem is that the early work back in the first 3 or 4 years simply did interest counting. You know, if you had 4 interests outstanding, that meant you had a certain amount of data coming back. But the problem is that the dynamic range of data that you might get back in response to a single interest could go from a few bytes to, like in the case of NDN, 64 kilobytes. So this is an attempt to change the equation here such that you're actually counting bytes on the wire as opposed to simply counting messages. And if we want to exploit the flow balance properties of our ICN protocols, it's going to be needed in order to get the best performance out of your congestion control. Thanks.
Okay, thank you. And then we also have the say microservice architecture draft that has been presented, I think, last time. And so we are currently discussing with the authors how to move on with it. It would be in our view, good to have a bit more like a concrete specification and a bit more than just like high-level architecture. So we're trying to move this into this direction. Okay. Any other activities I should talk about? No. Okay. Right. So let's start with the program. So I will do the first presentation, and I'll just do it from here if you allow me. Okay, let me introduce the topic a little bit. So transactions in ICN. So there has been quite a bit of work on ICN and distributed computing, right? So quite often we are dealing with problems that we have a group of nodes perhaps, or just a pair of nodes maybe, that are evolving a common state. And in a data-oriented system, you could think about, so what's the best way of doing this? So you could see this as a shared namespace and like an object tree. So it was like named data object that you can address individually. In ICN, typically these are immutable, so we kind of have to think about how to convey state changes. So what we typically do is we manage the state evolution by publishing new named data objects. And there have been protocols such as psync, SVS that try to do this in a certain way, so often for like a group of nodes. And so in distributed computing, of course, there is like one interaction that is often particularly interesting, and that is not always easy to achieve in a data-oriented system. So you have heard about the asset properties. I don't explain this now in detail, but typically these are easier to achieve in a client-server setting. So things like changing your bank account or something. And of course, we also know some distributed system, maybe blockchain-like systems and so on that try to do something in this direction. And so the question is, what is a good way in an information-centric system to achieve these interactions? And so when you do these things, so I thought about that there could be like different ways to realize transactions. So you could maybe see ICN a bit like a maybe IP or TCP IP replacement. It's like a network layer, and you assume you have like client-server communication between two nodes, or maybe in a group setting, like peer-to-peer connections between pairs of nodes. And then you implement transaction semantics on top of ICN and you use ICN as a messaging service. You would also do this in a different way. So you could record state changes in shared data structures and then share the structure in a group. So that would, like what I mentioned before, we had a shared namespace and then potentially additional like ledger functionality that manages those state changes. And so the question is, how centralized, decentralized would this be? And of course, you have to think a bit how you achieve certain asset properties, so especially atomicity. And so for the first approach, when you use transaction as like messaging over ICN, well, the like maybe default approach would be to use client-server communication between two nodes, and then there could be two different approaches. So you could have a really traditional layering. So you just use ICN, NDN like systems as a messaging layer, and then maybe you assign prefixes to, for example, client and servers if you want, and then send messages back and forth, and then you implement reliability, transaction semantics on top of that. There is also another variant that I called like ICN native communication. So you could use ICN interest data as a request response abstraction, and then you map the transaction communication and state evolution more directly to ICN. So this could be maybe seen like a cross layer or layer combination approach where you kind of try to leverage ICN properties. So today we talk. I think we talk about like these two variants. So this this one I just talked about. So use interest data as a request response abstraction. So for example, based on systems like RISE and reflexive forwarding. And then Mark is going to talk about another idea doing this based on manifests. And let me introduce the motivation for this a little bit. Jeff Burke and Lisha Zhang and we had a bit of a discussion, and we wrote up some ideas on a system that we called secure web objects. So this is essentially trying to move the web into a more data-oriented system. And if you remember, so the original web idea was a hypermedia system with document composability and application interpretability. So the original web idea was just a fabric that allowed you to connect all kinds of different information systems. So really heterogeneous. And it came more from an information management background. And so you had different types of link semantics and totally different types of applications. So not only static object access, of course. And so URIs were used to kind of link all this together with a universal identification or naming concept, independent of server notion or location. Today, the system looks a bit different, right? So, so the kind of e-commerce push in the early web and the security architecture that we inherited now is using TLS a lot for server authentication and also for bootstrapping secure communication between clients and servers. We have names, but typically for servers only, so DNS names. And so on top of that, so for any, say, serious application today is using an elaborate distribution of application logic, rendering, user interface functions. So there are these quite interesting frameworks, so like React, Vue, Node.js, and so on. So this could be seen as leading to a system that is like a virtual secure pipe between browsers and servers, and a bit like what we call single server applications. So it reminds you a bit of these old Minitel or BTX systems that we used in the past. And so when we discussed this idea, we said, okay, maybe let's take a step back. And so can we provide a system where the data-oriented nature of the application is better supported by the network system itself, so a data-oriented approach. And so can we enable web applications to create and exchange web objects without maybe relying on channel-based security? And where we just have like a set of uniquely identifiable web objects that can be secured independently or using like ICN-like mechanisms. And so what would it take to build a web-like infrastructure based on that? So we call this secure web objects. So application data units, so all kinds of web contents with the usual ICN properties. And then, of course, we would have a different trust system, so beyond the web PKI. So maybe using the ICN intrinsic keys and certificates. So this part of the motivation came from the idea of providing a system that worked well in, say, typical infrastructure, well-connected environments, but also in like local only environments. So there's like, we had a local first software presentation at ICNRG last IETF. So in that sense, we wanted to provide something that can do this, but also the like mainstream web. So this would probably have to go a little bit beyond, say, named data objects. So we probably would have to think about some other features, like maybe a bit more metadata to support computing in the network, so transformation, dynamic creation, provenance verification, and also things like group access control and key distribution. If you wanted to build such a system, so well, we think we have to support different types of interactions with maybe different protocols. So surely the web includes things like WebRTC. And so this is something that has been investigated quite well in ICN. So there's a nice paper by Giovanna and her team called Robust. So on a real-time system that could actually be used with ICN today. So we kind of know how to do this. Of course, there's always like room for future work, maybe supporting things like low latency streaming in large-scale scenarios better. We would need a concept for linking and aggregating objects. So for static objects, this could be based on a technology like Flick. But we will also need something that works well for dynamic content. Yeah, then there is, of course, opportunity to put applications together and coordinate them and synchronize state. So, so we have things like sync. Could be the question could be: is this ready for web scale deployment, or what else do we need? And then there is something like higher layer consensus, so how to map app semantics to an eventual consistency service. So there are things like CRDTs that have been investigated or are currently also investigated for building applications with NDN, for example. But then you, in the web, of course, you still have like transactions. So you still have scenarios where you absolutely want to change state in a system. So your home banking example. So not everything is just about accessing information objects. So some interactions are really about changing state and doing this in a durable, consistent way. And so if you think this from a like client server perspective, that's what I'm talking about here now. So what you need is a robust request response scheme in ICN. So we have discussed this previously when we talked about RISE and the RESTful ICN idea and reflexive forwarding. You cannot, we don't think you can do this with just interest data, so like with one round trip. So quite often when you do requests, you have input parameters. You may want to authenticate the clients before you commit computation resources and so on. So this seems to call for more like a session concept. And typically also one transaction does not come alone. So you often have a series of transactions. So so we were thinking about how to set up a session context with these properties. And in this RESTful ICN paper that Dave and I put together in 22, we described this idea. So we were using reflexive forwarding to connect to a server, enable the server to fetch parameters and so on. And then we combined this with an early idea from Park called CTNX Key Exchange. So that basically does something similar like TLS 1.3 security context setup. And in the original Key Exchange, the idea was to set up something like a tunnel, basically. So in our proposal, we wanted to use this for just like agreeing on doing the key negotiation, and then have the subsequent communication just work like normal name data object exchange. So like just interest data with signed objects, for example. And So we think this is a potentially good way of doing this, because it would allow you to have like a session-like system that you can use for implementing transaction, but you would still operate in an ICN native way. So for example, you could have systems where many, say, clients ask for the same object. You could use symmetric encryption and then to share those request results, for example. And when you implement this with reflexive forwarding, so this is a bit like a recap of the consequences of doing that. So we utilize forwarder state that is established by an interest sent from a consumer to a producer. And so the reflexive forwarding would then allow the, say, producer to get back to the consumer and fetch additional data. So the internet draft specifies this in more detail. So one consequence, or one say aspect of this approach, is that you need additional forwarder behavior. So all forwarders would need to be able to recognize these reflexive forwarding interest, and then also set up the state for the reflexive interest in the say other direction. So this is, of course, something that needs to be considered and discussed. But yeah, that's say our proposal of doing this, and we are looking forward to discussing this more. So whether people think this is a viable, good idea, or it's a totally wrong direction, and that's a bit the purpose of the meeting today. And yeah, so maybe I'll skip this because we talked about this already, and I have Dave here in the queue. Dave, do you have a comment?
Oh, I thought you might want to wait till the end. I just wanted to mention that those of us who have been around for probably 3 generations of mapping just applications in a distributed system onto the network protocols we have, there's lots of experience that is not really easy, and possibly a really bad idea, to try and make multi-way handshakes out of individual two-way handshakes. I mean, even classic transport connection establishment uses a 3-way handshake. Anything that tries to establish permissioned sessions like SIP wound up with multi-way handshakes with 2-way handshakes in opposite directions. And the state machine for that, I think it took 10 years to even start to get convinced that that was even close to correct. And then if you look at authentication protocols, none of them work as 2-way handshakes, right? Everybody who's tried to eliminate and cut down the number of round trips for establishing secure sessions of any sort, whether you use it just to get a data later or to have a channel that's secure, has discovered that attempts to do this wind up with broken authentication protocols, and the history is littered with these. So I guess I'm trying to put some thrust behind the idea that if we want to do anything like transactions or secure multi-interaction operations using ICN, it's not a good idea to just try and build that out of individual 2-way handshakes. Thanks.
Yeah, thank you, Dave. Yeah, and also, so we discussed this a little bit at NENCOM 2 weeks ago. And so the idea here is not to, map any particular protocol like HTTP or something. The idea is really to solve this problem of how to securely set up a session for these types of interactions. And there's a comment.
Mr. Zhang, I just want to comment on what Dave just mentioned. I think in ICN, or more specifically in NDN, authentication step is done not at the time when you carry out the transaction, but rather it is at the time when each entity joins the system. After that, it's just the secure data exchanges, transaction or not transaction. You do not do any further login equivalent security stuff anymore. Just want to clarify that concept.
So I actually disagree with that, particularly if you consider
I know, that's why I'm
authorization.
saying that. I just want to
Right.
present my view.
Particularly if you
That's how
consider
things
if you
work.
consider if you consider authorization.
Authorization is after authentication. Therefore, in the process of carrying out each operation, and then trust schema make decisions. But that's a part of the transaction. There's no additional steps per se.
But I believe there are.
Policy is executed when the data passes. When you receive a command, then the policy will dictate whether this command is or is not executed. That's it.
So
That's,
we'll talk more about this.
Kathy is not here, but that's what her software works.
Yeah, so I mean, this is a different perspective of doing this. So here, the assumption is that you cannot fully rely on this, say, authentication by, say, distributing keys and maybe have some trust schema. So here the idea is that you really talk to a server, and so the server maybe doesn't actually have to know your, say, network layer key identity, because there may be other ways to authenticate you, so username, password, and so on. And but I think it's a fair discussion to think about. So how could we realistically build systems with ICN in the future? So can we assume that we just have, say, a system where everybody has a key and everybody can verify these keys and so on? And of course, ideally that would be the case. But even if that's the case, there could, we think, would still be, say, application layer semantics that would require an additional step. And I think that's it's a good discussion. So Mark has a
Mark's in the queue.
Yeah.
Yeah, I was just going to comment that saying a protocol does or does not, do authentication, real time or ahead of time or whatever. I think there needs to be like a specific example given where one can trace what assumptions are being made, and you might have kicked some other can down the road, or there might be caveats about what it does or doesn't do. So I would say, like, if Leisha has a specific reference for something that we could then look at and compare with, that would be a concrete thing to look at.
Okay, reply is coming.
Well, if you've mentioned my name, so tomorrow we actually have a presentation at the ICNRG meeting where the students will present the very specific example of how this workspace works that started with authentication. And after that, then how to do secure object exchanges. Yeah, in our daily use of workspace, that's the experience. Students in my class tried this out. They just felt, wow, it's so different. No more login every time you get connected. Because once you're bootstrapped into the system, your credential doesn't get lost simply because you went offline and come online again.
All right. Yeah, so let me wrap this up. So the question is really how to realize those transactions, and so what you now discussed is also how should the authentication happen. So I think this system that Lisha just alluded to has some interesting properties, but I think it would be good to develop this further to like a web-like infrastructure and try to solve web-like use cases. So again, so this is not about mapping existing protocols like HTTP or anything. It's actually about, so what do we need to do to run and establish these transactions? And so is this ICN native approach here. So we realized, okay, it's hard to do this with basic interest data. And then that's why we came up with this combination of reflexive forwarding, key exchange, and then these transaction semantics. The downside is, as mentioned, that you need forwarder extensions. And so that would raise the question, how do we generally want to go about with extensions, and what other things might be needed? Okay, are there any other comments or questions? Right, I think we had a fair bit of discussion, so then I would hand it over to Mark to present a different approach.
Hello.
Yeah, give me 1 second.
Okay. Are you going to drive the deck?
I can hand it over to you. Just a moment.
That's fine. We can do it this way. So these are some initial ideas on what we're calling a transaction manifest as a way of encapsulating this idea of data consistency in an ICN specific format. Next slide, please. So, often one thinks of ICN as, a pub sub or a pre-published, not for transactional consistency. But you do have things that can offer transactional consistency, especially distributed ledger technology, especially permission DLTs, where you can have a small number of bookkeepers or orderers or whatever you want to call them, maintaining consistency for a large number of nodes. So we're going to talk about this transaction manifest concept. And this presentation is entirely skimming over the fact that you still need a client to, I call them bookkeeper protocol, and a bookkeeper to bookkeeper protocol, which would, take care of how do you submit a transaction, how does the transaction get approved or rejected, and how can you do bookkeeper to bookkeeper, consistency. That's not mentioned here. This is just about the data object. Next, please. So Flick is another type of manifest that describes how to encode a single object into a manifest that you can then reconstruct it. A transaction manifest is not that. A transaction manifest is saying what is the state that I used and what's the state that I'm writing, so you can construct the causality of changes. So kind of different things. Next, please. So, briefly, the transaction manifest, needs to say, what are my preconditions? What, if you think of this like a database, what rows did I lock or what rows did I read for me to make a decision about what I'm going to write back out? So it's a way of saying, what state has to be consistent on my input, and then what state am I trying to write out consistently on my output? Like if I'm doing an unconditional write, there'd be no preconditions. If I'm doing a transactional write, but there is no pre-existing row, just use the database analogy, then there need to be a special token that says, I tried reading this name, it doesn't exist, so I'm basing this write on the non-existence of this previous element. Next, please. So not all preconditions need to be in the transaction. So for example, if I'm doing an employee badge, I might take any photo of the employee as a valid photo if I think it matches them, but I have to be transaction oriented on their access level. So the transaction manifest might have a precondition about Bob's access level, but we just picked a photo of Bob and we embed it in the badge and we say, this is where I got the photo from. That's not really a transactional piece of data. So next, please. So as I mentioned, there needs to be a protocol by which you're submitting these objects to something to actually do the transaction and say, all your preconditions were the current state of those preconditions, and there's no conflicts on your post conditions, so we're going to accept your transaction. So things like Hyperledger do this already, so one difference is the transaction manifests essentially are creating partial orders in the data, because they're just based on my specific preconditions and my post conditions, and as long as you ensure that at the time that they're accepted that they're correct, then the whole system can proceed without a global synchronization. So that would be one difference from perhaps other ways that this has been done before in ICN. And then it's the bookkeeper's jobs to make sure that the preconditions are correct, post conditions are non-conflicting. And this is essentially like creating the write-ahead log that's used in many databases. So we're writing a log entry and doing that and making sure that it works before committing it. Nested transactions could happen. Yeah. Okay. So there's a later slide on that. So yeah, next. So this is just my kind of initial thoughts on how repos and caches would interact with transactions. My thoughts would be that a repository shouldn't reply with a post condition unless it has all the preconditions available. So I shouldn't be able to read an updated object unless all the preconditions are also available. And a repository should be able to respond with the transaction manifest that wrote the post condition to be able to provide the causality chain for objects. Those are just my kind of initial thoughts about what a repository should do for transactional data. Whereas a cache should just cache and do whatever it's asked to do. And applications should use non-cacheable discovery, if they need to get to a consistent state of something. Next, please. Naming. That's always the fun part of ICN. So, obviously you can have user-specific naming where Alice kind of says, here are my transactions for a database. That might get kind of messy. Or within a database, you can have, transactions written by each user. There's probably a lot of other there's a lot of other options for this. What you probably can't do is write the transactions based on the post conditions, because you might have multiple post conditions, and then what would you name it? And next, we're getting towards the end here. Distributed transactions. So what happens if a user names objects that belong to different sets of bookkeepers? For example, there's an order database and a parts database, and when you place an order, it has to reserve parts from the parts database, and those were separate synchronization groups. So, of course, you do nested transactions or hierarchical bookkeepers. And again, this is getting into, there needs to be the bookkeeper to bookkeeper protocol about how they talk using these objects, which is clearly not done here, just kind of a little thought-provoking stuff. So
there's a question by Dave. Do you want to take it? Yeah.
Oh, sure.
It's just a real quick one. With the minute you have these kinds of multi-bookkeeper systems, you're into the world of having to deal with live locks and deadlocks.
Yep.
In classic systems, this is unfortunately enforced by ACID-style total orders, right? And the question is, can we actually do this without enforcing a total order?
Because it's name based, so the initial transaction that goes in is essentially naming the rows in the child database that it's preconditioned on. So maybe, I don't want to claim magic in distributed transactions. So, and so partial orders have been used in the database world, but I'm not super up on that literature. So definitely, that needs to be looked at.
Yeah, I haven't seen it for multiple uncoordinated databases though.
Yeah,
that have different root properties, right? Maybe. I don't follow that field. It's definitely an interesting topic. Thanks.
Right. Yeah, I mean, it'd be interesting to see if such a thing could work. Yeah, because the transaction manifest doesn't require a read ahead lock. So all these things are, this is still lockless. So transactions can fail if there's multiple updates. And clearly there's unfairness because, the user who is trying to do this over some, awful, 4G link is going to lose out to the guy who's like, writing the database on his gigabit fiber.
Okay. If you make that proviso that you can actually cause a live lock or a starvation,
right? Yeah.
Then I'll withdraw my comment. You can actually do that without total orders.
Yeah, and now I don't know. I don't think that those are desirable properties. So when I said one needs to develop the bookkeeper to bookkeeper protocol, one needs to decide, how am I going to address unfairness? How am I going to address lack of progress by some nodes? Okay, yeah, great question. Thank you. 10. So yeah, that's shorthand for next slide. Right. So clearly one would need to sketch out, the client to bookkeeper protocol and the bookkeeper to bookkeeper, both within and between consensus groups, analyze that because it's going to be a complex distributed system, and then prototype, assuming it doesn't do something too stupid. So, all right. Any more discussion? I probably whizzed through that, but
yeah, thank you, Mark. Any comments here in the room or online? I don't see any. Okay. Thanks, Mark. Let's move on. It's Mark again. So I let Mark introduce this topic. So I passed slide control to you. You can advance the slides.
Okay, great. So at the NDN community meeting during one of the presentations, I mentioned, hey, there's this thing called Vanadium that does a distributed access control. And so I thought it'd be interesting to just introduce this in a little more detail. I'm not a Vanadium expert, so this is based on my just readings of their materials. I haven't had time to really delve into their software to see how it truly works. So but there were a lot of topics that looked interesting for the ICN community. So Vanadium claims that it's a secure distributed RPC system. So basically all the exchanges are based around RPC calls. It's not a content system, in the way that we think about ICN. It has distributed naming and discovery. It can use symmetrical authentication and encryption. And it can also do private name discovery if you want to use identity-based encryption, which obviously has performance constraints. This was developed at Google. There is, I believe that there is some IP around it, because in some of the software I've seen a grant in the software, but I believe all their software is like MIT or a permissive license. So Vanadium, basically, they broke it into two parts. They have a security part, and then they have an object naming and networking part. So in the security part, you have principals. So a principal is a public-private key pair. And then there are blessings and caveats. So a blessing is essentially the co-signing of a certificate for a purpose. And that purpose is generally an authorization step. Like, Bob can read some other name, or, Bob is authorized to read, but he can only do it between 6 p.m. and 9 p.m. And, it's an RPC system, so those sorts of things are implementable. They also have third-party caveats, which have to be discharged before the authorization is considered complete. And they use these for revocations and auditing. So when there's a third-party caveat, you have to essentially make another RPC call to get a discharge for that item. So they use these for example, revocation, and they also use it for auditing. So for example, I have to send out a notification to the auditing process saying, hey, I'm doing this thing. And when it says, okay, I've logged that, and I can present that to the RPC server, the RPC server will then go and do the thing for me. For communications, they use what they call a mount table. And this is a lot like a POSIX mount table. So this describes about how to locate RPC namespaces, and it provides some amount of relative naming. So I'll get into the details of that in a little bit. So how ICN-ish is Vanadium. So the security part is pretty ICN-ish. They do prefix matching. So, like if you have a namespace Alice, there's a certificate to some principal Alice, and she would be considered authoritative for the Alice namespace, and she can then start creating things like her home TV or her house guests and add people into that. So she could bless Bob to use the name Alice House Guests Bob, and Bob could then have read to her TV, for example. They do prefix matching. So if Bob is blessed with Alice House Guests Bob, he actually matches Alice. So and he matches house guests. And they have a way of just saying, no, it's an exact match by using the special terminator. So it's a kind of interesting way of, essentially creating namespaces and groups for doing security assignments by doing the prefix matching. So some examples, these are taken directly from the Vanadium GitHub. You can have a principal Alice, using the namespace Alice, and she can bless the TV principal to use the name Alice Devices Home TV. So if someone queries for that, it would be authorized to say, yes, I can handle an RPC call for that. You can then put caveats on those. So Alice can say Bob. If Bob is using the namespace Alice House Guest Bob, he can do that as long as the server is matching Alice Devices Home TV. So server is kind of the link in to the object naming. So all these things with colons have been principal names and certificate names, whereas server is getting into the object namespace that you would then resolve. So, the fun part, roots of trust, PKIs are great, but they always come down to how do you know that you should trust this key to do something? So Vanadium kind of skirts that whole issue. They did at some point run their own identity service that could map an OAuth 2 into Vanadium objects. So you could get a user blessing and an app blessing based on the OAuth, and your application could then go off and, if it trusted this dev.v.io principle to bless other names, you could then have a fully running service that had a root of trust. But in general, if someone wants to write an app, they have to either make their own root of trust or figure out how to do it on their own. They also ran a discharge service for third-party caveats that could be used for revocation. And they chose a revocation service rather than short-lived authorizations for their use. So object naming. So now this is the weird thing about Vanadium is they then have this whole other namespace, which is basically the RPC namespace. So you had the colon names, which were for principals and certificates, and then you have this object namespace, which is how you actually resolve an RPC server and make requests. So they call these mount tables, and they say it works a bit like recursive DNS. So when, if client 1 mounts the ns1.v.io port 8101 mount table, it can then resolve the names A, B, and C under that. And those point to new mount tables. And so, I can resolve, A/Y and A/Z by going through these recursive walks of mount tables. And even within the same application, all clients don't need to mount the same mount table. So, like client 2 might only be able to resolve the names Y and Z because it only can mount that second mount table. So this is a bit clunky, I think. You can also name servers in this, right? So there could be a /SRV, which resolves to server 1, and a /A/SRV, which resolves to server 2. And you're essentially calling a get function or some other RPC function, on these mount tables. They also do it a little bit like a query string. So that's probably a bad analogy, but if there's extra name components left over, like you ask for a SRV foo bar get, you've basically resolved a server after SRV. So server 2 would be called with foo bar get as an argument. And they also permit cycles. Okay, so right, so that first name component is essentially an endpoint, and that could be a DNS name, an IP address name, a MAC address that they use for like Bluetooth. So they are embedding the some locator in the first name component. And that's kind of serving a dual purpose of being a locator and kind of a root of trust for that mount table. Okay, so wrapping it up. So Vanadium it's a permissioned RPC service. The name encodes the object name, encodes an endpoint and a suffix. and so everything is done by RPC services. The endpoint doesn't need to resolve to a single mount table server. Like if you're using DNS names, you could always pick an appropriate server. And it could be any server that possesses a blessing to operate as that name. Authentication is done via pairwise key exchanges, and it could be a private key exchange, meaning like the server's identity or the client's identity is not known ahead of time if you're using IBE. And it has the authorizations and blessings and caveats that use the hierarchical prefix matched names. So what does this mean for ICN? So I think the security piece is interesting. The blessings and caveats are the blessings at least are a little bit like the co-signings of SDSI, but they integrate specific authorizations into them, and you can via the caveats have all sorts of different restrictions or third-party discharges that you have to resolve to do something. And you're always proving that you have the private key for something before you get to do it. And their identity service, they had an interesting way of mapping an OAuth to authentication. So mapping those tokens into their PKI and blessing scheme, whereas the RPC piece would need, I was kind and called it a bit of finessing. It would need an overhaul to make that piece fit into the ICN structure. But maybe one could think about can you incorporate a root of trust as part of the name, and would that make sense in some context rather than have the initial piece be the routable piece? Could it be some sort of root of trust piece? And I think in a subsequent discussion, this session, we're going to talk about global and scoped namespaces and things like that. So maybe we could talk about what are you going to believe? Are you going to believe DNS or routing or a public key, or how do you really get to what you trust? So that's my whirlwind tour of Vanadium and kind of how it might map to ICN. Maybe we could get one of the Vanadium authors to talk or chime in at some point to get a more authoritative breakdown on it.
Okay, great. Thanks, Mark. So is this coming from like what's called meta home networking world, or what is it intended for?
Right. So I think that they intended it for like mobile to mobile applications, and they do have some sample applications. They have a distributed database, a peer-to-peer database they called like SyncBase, that they wrote over the Vanadium core, and then they have a couple applications based on SyncBase. But I suspect that this was all done, basically for Android and mobile applications.
Okay, good.
That's all guessing.
Kind of, Dave.
So something that would be interesting to do is to try and do an apples to apples comparison of the security piece of this to trust schemas in NDN, because it seems there are two things going on here. One is that the NDN trust scheme is sort of are biased toward a centralized management of the entire schema as a data structure, and this seems to be much more granular in terms of how you can incrementally evolve the trust schema as principles are added and removed from the system, and as objects that need to authorizations to be accessed get added and removed from the system. Plus, I mean, there's some additional capabilities in terms of caveats and discharges that are not currently in the NDN trust schema architecture. But it seems like you could do everything you can do with NDN trust schemas with this, or am I missing something?
I suspect you could. But and like you said, I mean, this is much more free form, and I mean, I've always been a fan of the SDSI co-signing, and tried, once or twice to figure out how we could do co-signed objects in CCN, but that never really got anywhere.
Even if you use Dan Bonet's multi-signature schemes? I know they're a bit expensive, but
yeah. So, well, I mean, the SDSI is just really basic. I sign an object that was already signed by someone else to give it some additional property. So yeah, it's not multiple concurrent signatures. It's more like signature wrapping.
Yeah.
But yeah, I think that would be interesting, is to, well, I mean, since they have this sync-based application, and I think that they have like a chat application built on top of sync-base, it would be interesting to see, how does that map to, like, the NDN, one of the NDN syncs and one in the NDN, chat. I mean, the current NDN chants are CRDT apps, but it would be interesting to kind of, map those and see what's what, and, maybe there's interesting features that could be takeaways.
Okay, cool. Thanks, Mark.
Okay, sure.
We had a plan to discuss global versus scope namespaces. Do you have anything extra, or is this the discussion already?
No, I didn't have any like slides or anything prepared for that. I just thought, there's it might be good to kind of, talk about, again, it comes down to, how do you know that the key that you're looking at is the key that you should be looking at for believing that something should be done or should not be done? And I think that's probably, the hardest part. Like IPFS just totally punts that.
right.
When you read their process, they say, out of band, figure out the CID that you want, right? Just totally ignore that. There's a little bit of trust, with IPFS and DApps, based on like Ethereum, but like CCNX uses public key scoped names. So in the interest, you can put a public key publisher ID and say, I only want this name if it was signed by this key. But again, you need to figure out what key you want to use for that. Whether that's like Dane, or you're getting it from DNS, or you're getting it from the app that's baked into the app, or getting it from, who knows where.
Yeah, Dave.
So, not to be snarky, but we need to remember that auto-configuring security is an oxymoron. So there has to be some kind of, quote, out-of-band or leap of faith operation, right? That you can use to bootstrap, whether there's some trust root that you're going to believe to leverage everything else that you do, right?
Yep.
And trying to make that happen via some discovery process or some auto configuration, I think is basically doomed to failure, right? Because there's always a leap of faith operation that something outside the system has to point to something and say, yeah, that's it. But one of the things when you mention scope namespaces versus non-scoped or global namespaces, something was done many years ago that may be worth looking at again, was this RPC system done for the OSF distributed computing environment. And what they did for namespaces is that namespaces started out local. They were all scoped. And when you generated a new scope namespace, it got effectively a UUID, which was sort of a public name for the trust root public key for that scope namespace, right? Now, there was nothing in the system that allowed you to get that, decide whether to believe that key based on only having that UUID. But assuming somebody made that assertion, you could bootstrap a lot of things. And I think the key innovation there, actually done by Butler Lamson and company when they were at DECCERC, was there was an explicit operation that could attach your local namespace to a more global namespace. So your trust root could become a named directory or tree part of a larger namespace. And that operation could be bootstrapped through an authorization procedure of the owning namespace. And the nice property there is that you could grow things from the bottom up. And ultimately, you know, if somebody decided that the root of DNS was very Earth-centric, and the aliens showed up and said, gee, we really want the root to be Milky Way galaxy. Okay, we'd have no way to deal with that because all the authoritative pointers are from parent to child. Whereas in that system, all the authoritative pointers were from child to parent. And the downward traversal was simply an optimization operation, so you didn't have to, you know, flood to search the whole galactic namespace. So those things may be worth looking at again, rather than sort of being stuck in this, do we have a scoped local namespace or do you use a global namespace? There could be a way to evolve into progressively more global namespaces out of local namespaces if we actually have effectively a name for the trust root that is by design next to impossible to collide with the name of a different trust root.
Yeah, the vanadium, just to, you know, so I mean, one thing that their mount tables do allow is, you know, they call this, you know, it's a relative naming scheme. So, you know, if you say A is Earth and, you know, what the client one is pointing to is like Milky Way, right? You know, people who used to access the Earth could then be moved to the Milky Way and resolve, you know, /Earth.
So there were naming systems that used relative naming, and they all basically fell apart on the issue of, I compared two names, are these the same thing?
Yep.
Right? That computation is actually not, I don't know whether it's mathematically impossible, but it's computationally infeasible.
Well, so, you know,
the operation of is this name the same thing as this other name? That's actually a fairly frequent question you need to answer. And the relative naming systems can't answer that question.
Yeah. So in the way that we structured Flick manifests, you can always write a new root manifest that points to a previous manifest, and you can give that root a new name. And there the operation of saying, are these two things the same, is very simple because
right, but that's because it's still hierarchical and you're growing from the top down.
Yes.
Right. The assertion that some sub-manifest is part of this larger manifest is an assertion by the larger
Oh,
manifest.
yeah. That you wouldn't be able to tell unless you had some way of retrieving all parent manifests
Right.
for it. Yeah.
So the interesting inversion here that may be worth looking at after all these years is growing things from the bottom up, with the authoritative pointers being the child to parent pointers. Right. So orphans have enough state to computationally find their parent if the system gets disconnected.
All right. Any other comment on this, or any idea, question? Great. Okay. Thanks very much, Mark, for bringing this to us and looking into vanadium. Yeah, let's keep that discussion going. I think it's actually quite interesting. Okay. Just a moment. So that concludes the meeting today. Just quickly, upcoming events. So you may have seen on the mail list, so that ICMP this year solicits ICN submissions. So for people in China, this is a CCFB class conference. And so it's going to be in October, end of October, in Charleroi in Belgium. And the deadline for paper submissions is May 24th.
And there are explicit ICN-ish things in the call for papers.
Yep.
And the program committee has an area chair for ICN. So there'll be somebody specifically watching to make sure that the ICN papers get the right kind of reviews.
Right. And in addition, so yeah, we'd like to get more input from you about future ICNRG meetings. So one option that we thought could be so do something as an interim just after the ICMP deadline. That's when people typically have good ideas and some things to talk about. So at least one of us will also be in Vancouver, so that could be another opportunity. Another option is, of course, to chill a bit and see what happens on the main list. So we'd like to hear your opinion. So either now or on the list. So please let us know what you think. If you have something, please share your thoughts. Okay, see me in the hallway, and let's make a good plan for the next meeting. Thanks everybody for coming, and this concludes the meeting today.
I'm sorry I couldn't make it to Brisbane, but hello to everybody. Sorry I missed you. Yeah. I'll be in Vancouver, however, so let's hope we can actually have some in-person time there.
Yeah, thanks for joining online, Dave and Mark and everybody else. Bye-bye. So that's what I promised.